Okay, so very good morning. Am I audible? Okay, so let's start. So we have completed around 5 to 6 lectures, and the content that we covered is mostly and basically contents because in the first unit we are dealing only dealing with the introductory part, and that introductory part will give you just an basic idea about an plastic and what is actually important is the way of processing, because ultimately see we are not going to be at a much more deal about the chemical part of the plastics, right? So mostly in your other subjects you may have gone with this iron material, ferrous and ferrous based materials, because in mechanical engineering most of the applications are based on this ferrous and non-ferrous materials, that too mostly ferrous materials, right? So whatever the applications, properties, structural analysis, everything that you generally deal with ferrous based materials, right? So this is like an allied material, as I told at the start only, the plastic, and the reason behind studying of this particular plastic is that uh, the level of application that currently, because if you see everywhere, as we discussed earlier also, we have seen also that moreover at every place you will find this use of plastic, and right. So as I told earlier also, from start of the day to the end of the day you will find everywhere this plastic. There are some advantages, there are some disadvantages also. It is there for each and every material, but being a less being having a very less cost, it may be used for so many applications. So because of this more applications of the plastic, we are studying about this particular material. And one more important thing that I told in earlier lecture also, no any material is used in its original condition or in original structure or original format. Original in the sense pure material. So I have given you the example of gold also. So when you will visit an jewelry shop, so there are so many categories, and 25 carat, sorry, 24 carat, 22 carat, right? So like 24 carat is more pure than 22 carats, and the rates are also different. So, and though 24 carat is more pure, still it is not 100% gold. There is addition of some amount of copper and other materials, because see, pure gold is not that much ductile, and gold mostly, or 100% the applications of gold are in the jewelry, which is having a very complex shape. Small gold particles are molded into complex shapes, okay, and that required to have a good ductility. And if you check out with the pure gold, it is having a very less ductility. Pure gold. So to increase the ductility, some amount of copper can be mixed, because copper is having a good ductility. So that addition of copper will lead to the increment in the ductility of the gold, right? But obviously it is going to be in a less amount, right? So that way every material is used, and this is how the new concept started generating, that is a composite materials, right? See, plastic is also of the same kind. A pure plastic, we cannot use a pure plastic. We can, but whatever the need or requirements of applications are there, according to that, a pure plastic is not desirable. Okay, so so to overcome that, when that composite concept started, then after this plastic has emerged as a for a maximum number of applications. Okay, basically earlier it was there in use, but for limited number of application. But when concept of composite material has started, then this more applications you will find from the plastic, right? So that's why we are studying about the plastic, and now everywhere you will find this application of plastic. Depending on the chemical structure, these properties of the particular plastics are different. Okay, we have seen so many types of plastics. Polyvinyl chloride, like a PVC pipe, ABC, okay, which is there for manufacturing or the production of the electronics components, right? Some type of plastics are used for food packaging, as a food packaging materials. Polyethylene tetraphthalate, which is used for PET bottles, popularly known as a PET bottles, polyethylene tetraphthalate. Then polycarbonate is there, okay, for your disc and suitcase type materials. Okay, so uh, everywhere you will find nylons, okay, a thermoplastic material, acrylics, epoxy, polyester, textile used. Okay, so so many applications, and these the variation of plastic is due to the variation in the their chemical structure, okay. And the basic unit of this chemical structure, now we are just touching to the chemistry part, okay, but not at that much of depth. Okay, just an overview we will see. So you have studied in your 12th about unit cell. Getting it? Unit cell is a small building block for a large structure. For example, if I will give a generalized example, if you see a building or a large your structure, large room or large wall. So if you see an building, the small unit of that building is that small concrete structure or brick. Okay, that small brick is a unit, single unit of that large structure, and we can call it as a unit cell. It is important because this addition of unit cell will create a large structure. Similarly, here there is a term called as a monomer, and then polymer. Okay, that we are going to study today. So the definition we have already seen. Plastic, if you can recall it, the material which can be remolded or which can be reshaped by using heat and pressure. Right? Classification of plastic material we have already dealt with. So natural plastic, synthetic plastic, that is the basic. But moreover, it is a thermoplast and thermosetting. Okay, right? Basic difference is that when one plastic is heated, it will melt down, and when it is cooled, it will solidify. That is thermoplast. And another plastic is that when you will heat that particular plastic, it will start solidifying, it will start making a hard structure. That is a thermosetting. Thermosetting, provide the heat, it will settle down. Okay, it will settle as like a solid material. That is a thermosetting. So that classification also we have gone through. Properties of plastic we have already seen, that is a very less density, good moldability, flowability is good. Okay, so that complex shape can be prepared. And then applications, right? So depending on the chemical structure, we have seen the applications also. Testing methods, right? Testing methods like tensile test, flexural test. Okay, and then additives in the plastic. Additives in the plastic, you can consider this as a I have given you the example of gold. Similar way, as per the need, there is addition of another materials in that plastic so that you can have improved properties. Okay, and the next concept is of monomers and polymers, and then polymerization. Monomers, polymers, and polymerization. Okay, and the types of polymerization. Right? Okay, so that point we will see today: monomer, polymer, and polymerization. Okay, just one thing I want to notify you. that possibly maybe in between I need to leave the session. That time I will inform you, and we'll continue the remaining part of lecture when there is another one more lecture in afternoon session. Okay, I have one urgent meeting, so I will inform you in advance. Okay, not now. So the that we are going to study is the monomers, polymers, and polymerization. Let's see the first part, monomers. Okay, don't look at the structure given at the end of this PPT. Okay, see, we are not going to because see, chemistry is now far behind, or that it is not in our consideration. Again, if you start studying about the chemistry, it is a very it is a totally a different part. Okay, so just we'll see the examples. So the first is a monomer. Okay, the word itself is explaining the meaning. Mono means a single. Okay, and mers means unit. Okay, single unit. Okay, monomer stands for a single unit. Getting it? So it is like an unit cell. Now this unit cell concept you may have studied in a metallurgy also, right? Unit cell. Okay, so the monomer stands for a single molecule which is having two or more binding sites. Now this is a very important one. A simple or single molecule with two or more binding sites, right? Now what is the mean by two or more binding site? Come to this picture that is given at the bottom, right? It is a monomer. Okay, and see, this is one site for bonding from the carbon at the right side and one at the left side. Okay, so because of this monomer, what is going to happen when next monomer is required to add here? So another carbon atom will attach to this side one carbon, and this side another carbon. Carbon means this complete linkage. So there is a possibility of linking from this right side also, and possibility of linking from left side also. Why? Because there are two bonding sites. Okay, it can be more also depending upon the monomer. Okay, but at least there should be two binding sites. See, if there will not be any bonding site, this polymerization is not possible. This is a this is a simple monomer, and monomer is of no use unless and until it is acting as a single unit. When it will combine with more number of unit and it will form a chain, then it will have some proper existence. Okay, polyvinyl chloride, for example, PVC pipes, polyvinyl chloride. So there is a one monomer of vinyl chloride, and that will form and a chain that is called as a polyvinyl chloride. Poly stands for multiple. Okay, so meaning of monomer, a simple molecule which is having two or more bonding sites or binding sites. Okay, which is called as a covalent bonds. So here is the one bonding site, here is the one binding site. So additional monomers can attach here, can be attached here. Okay, and it will form a chain. So it is given as a n. Small n stands for a long chain, n number of monomers. Okay, that way. So this CH2 HCl will stands for a single monomer. Okay, CHCl. So a simple definition: simple molecule with two or more binding site through which it forms covalent linkage with other monomer molecule to form macromolecule. Okay, you may be aware of this macro and micro. Okay, micro is the smallest, micro is the smallest, and its larger form will be called as a macro. Okay, micro will combine together and will form a macro. Okay, so if I will say monomer is a micro, polymer is a macro. Monomer is a micro, polymer is a macro. Okay, so that way. So a simple molecule with two or more binding site so that it can form a covalent linkage or a chain, that is called as a monomer. Now the second statement: all simple molecules cannot behave as monomer. All simple molecules cannot behave as a monomers. What is the condition? Only those with two or more binding sites. Only those with two or more binding sites. Because see, everything is analyzed with respect to application. If any material is of no use, then there will not be existence of that particular material. Getting it? Okay, so it may be this monomer will be used when it will appear in the form of chain. And when chain formation is possible, chain formation is possible when there is a possibility of binding, there is a possibility of covalent bonds, possibility of linkages. Okay, and so that there will be existence of monomer when there are two or more binding sites. Okay, so these are some of the examples. Alkenes, vinyl chloride, from which polyvinyl chloride is prepared. Okay, adipic acid, glycol, right? So these sites are acting as a binding sites, this way, right side and left side. Okay, keep it in mind, monomer is a single simple molecule with two or more binding site, so that a polymer can be formed. Okay, second part, a polymer, right? Now monomer you understood. Now the polymer, simple. Poly stands for multiple, mer stands for unit. Okay, it was a monomer, this is a polymer. When number of monomers will come together to form a chain, how chain will be formed? It will be elongated to this side through this opening, or through this bond, and through this bond. Okay, so it will be elongated this way and this way, and it will form a chain, and that is called as a polymer. Okay, so polymer, any of class of natural or synthetic substance composed of very large molecules called as a macromolecules, that are multiples of simple chemical units called as a monomer. Okay, so simple definition: when monomers will come together and form covalent bonds and form a chain, a long chain, that time it is called as a polymer. At the time of exam, if you are not able to recall these words, natural, synthetic, okay, no problem, just make it as simple as possible. Combination of monomers, a simple chemical unit, combination of multiple monomers to form a chain, is called as a polymer, is called as a polymer. Okay, so these are some of the examples. Polymers make up many of the materials like proteins. Okay, protein is also polymer, a long chain. Cellulose fibers, nucleic acid. Okay, now see, here is the example, just look at the picture. This is a PVC polymer, right? And if you see the chain, if you see the chain, there are repeating units, there are some repeating units. Okay, check the repeating unit. What is the repeating unit? CH2CHCl, that is called as a vinyl chloride. A single a single unit, that is a CH2CHCl, CH2CHCl, this one CH2CHCl, or here it is given, here it is taken out separately, CH2CHCl. Okay, so this is a simple monomer having two bonding sites. Look at, suppose I will take the first one, CH2CHCl. So from this H side there is one bonding site, from this C side there is one bonding site. So it will get a continuous linkage this side also and this side also, right? So it will form this linkage, that is called as a polyvinyl chloride. Okay, okay, so this is continuing this way also and this way also, right? So this is called as a polyvinyl chloride. When vinyl chloride monomers are combined together, see, combination doesn't mean that simply addition. Okay, physically it is a different, at the chemical level it is a different. Okay, there is a proper reaction. Okay, so polymer stands for uh, formation of a chain through the monomers, formation of chain through the monomers. Okay, now see, we have gone through monomer, a simple unit with a two or more bonding site. Simple definition. Polymer, a chain of a simple unit, there is monomers. Okay, chain or longer chain of multiple monomers, that is called as a polymer. You can give the example. Monomer is a vinyl chloride, polymer is a polyvinyl chloride. Monomer is a ethylene, polymer is a polyethylene. Okay, carry bags. Okay, simple monomer is ethylene, and Polymer is polyethylene. Okay, like ester. Ester is a monomer, and polyester is a polymer. Next, polymerization. Now it is very simple to define. Process of making a polymer is polymerization. Okay, how the process is happening from monomer to polymer, from monomer to polymer. Monomers will come together and form a covalent bonds with each other, which will result into a long chain, which is called as a polymer, and the process is called as a polymerization. Okay, poly stands for multi, merization stands for sublimation or combination. Okay, so process of combining monomers together to form a polymer is called as a polymerization. Is called as a polymerization. So here is the definition given: polymerization, any process in which relatively small molecules called monomers are combined chemically. Important. Okay. So simply addition is the word, no problem. Okay, but addition, don't take the meaning as it is. Don't take the meaning as it is. Addition in the sense a chemical addition, or a simple word, a reaction. Okay, to produce a very large chain-like network. It's called as a polymer, and this process is called as a polymerization. It's called as a polymerization. Now, the monomer molecules may be all alike, or they may be represent two or three or more different compounds. Okay, a simple thing. See, depends on the structure. When there is a chain of similar kind of monomers, CH2, 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 this can be there, or CH2, Cl, CO2, CH2, Cl, this can be also there. That means chain can be of the similar kind of monomers, chain can be of the two or more different kind of monomers, depends. But only the basic condition is that there should be two or more binding site. Okay, so three concepts you have to keep it in mind: monomer, a single simple chemical unit having two or more binding site; polymer, a chain like structure made from the monomers. Simple. Polymerization, process of formation of polymer from the monomer. Getting it? Okay. That is called as a polymerization. That is called as a polymerization. Now, basic two types are there. Just a minute. Good morning, sir. Uh, are you here? Yes, sir. I'll come in 10 minutes. Just I'll complete the lecture and I'll come in 10 minutes. No, actually, all the people were in a meeting, so it was difficult to adjust that I have conducted. In a 10 minutes, I will wind up. Yes. Okay. So, two parts are there. That is addition polymerization and condensation polymerization. Okay. So, we'll stop here. I have some urgent work. So, do one thing. Just put up your roll numbers in a chat box and leave it. In the next lecture, I'll complete the remaining part. Okay. So, thank you so much for joining. Just put your roll numbers in a chat box and you can leave now.